Alright, this is a demonstration of David Howarth's O-scale turntable. At the present stage it's far from finished, but certainly operational. Now the first thing we need to do is use the little toggle switch to show the direction we want it to travel. Then go to the other toggle, there's only two to operate it, and turn it on. So then away it goes. And what we want to do is get it around to the first stopping position, or when it's getting close to any of the stopping positions really. You just flick the switch to tell it to stop, but it keeps going at a much reduced speed until it gets to the position where it stops. And if we wanted to go a bit further, turn it on again and off, and it goes to the next one. We'll always, when you turn it on, it will always start at the higher speed, like that. And as it approaches the stop position that you want it to pull up at, it slows down and stops nicely at that position. Now if you overshoot the mark, you can come back to our direction toggle switch, change the direction, go back to the on switch, turn it on, and then it'll proceed in the opposite direction and come back to the position where you want it to stop at. You can probably hear the clang of the positioning pin as it leaves the metal disc, but we can fix that with some damping tape I'll put on there later on in the piece. So underneath, with it operating, you've got the mechanism, the double reduction from the Datsun windscreen wiper motor that runs it through a couple of small gears that I had in stock here from some other failed project, running through an old Ford, I think it's a Prefect starter motor Bendix gear, onto a Nissan SR20 flex plate, or ring gear if you like, or flex plate with the ring gear, and that gives it quite a reasonable speed. The disc that's got all the holes in it are all set according to the position where we wanted it to stop at, and to operate that there's a solenoid which is around the other side. Come around here and see if we can see it from this side. Oh, I forgot to bring my light with me, hang on. This is another Cecil B. DeMille production. But you've got the solenoid section that drops the little pin down into the hole. In fact, if I put that in the stop position now, you'll be able to see that. But just bear with me again for a minute. Have a bit of a look around the den of iniquity here. We'll let it get to a position where it's going to go for a little while before it stops. This video won't go to the world, I don't think. I don't think it's quite up to that standard. It's just a quick one to show you what's happening. The rollers on the end of the bars are much more robust than they were before and adjustable for their positioning. Now I've let it go past that spot, so we'll just go back here again, and then I'll go back and we'll see the pin drop into its little hole when it gets to the position. So we'll just let it run around. It's approaching the section, I think, where the trains will come on. So I've turned it off now and it'll just carry on slowly there. come around here, when it gets to the position you'll see the pin drop down into the hole and stop it. You see there's a bit of distance for it to go there yet. Another inch or so. There, see the pin drop through, and that at the same time that the pin drops through and locks the turntable in its position, the micro switch above actually shuts off the motor. Got a relay over here which turns on the resistors to give it the slow speed, but that'll be a bit more easy to understand that when you see the circuit diagram. Anyway, everything seems to be working alright. Sorry about the poor quality of this, but I'm trying to look at the thing and look at my camera and everything else, and it's a bit hard to keep up with it all. I'll make a better video later on. Anyway, there you go. Alright, here's a bit more that I forgot to add before. The centre section of the bridge is held onto the top of the shaft that comes through off the old side valve forward water pump bearing. Well, it's not that old, it was new once, but it hadn't been used very often. So I've got the 3 little screws on the top in order to take the drive from the shaft that comes through into the actual bridge itself. So this piece of metal plate that I've got in here, I put that in there. That gives it some springing effect to hold the whole bridge onto the track to keep it nice and firm. It won't twist, so it keeps it rigid. Originally I just had a couple of pins into a slot, and that slot only had a couple of thou clearance, but it was enough to make the movement at the end of the bridge quite big, so that was no good. So I had to fix it solidly on to the bridge. Then the first one, I just put a piece of plates, one of these plates through, and that wouldn't allow it to flex up and down enough. Not that it needs to go very much, but I wanted it to be able to compensate for the 1 or 2, or no, not 2, but 1 to 1.5 millimetres difference in elevation as you run around the rail around the outside here. It moves up and down just a little bit, and I didn't want it to bind up or cause any problems. So this end here, I put a bit of a concertina in it, so that as it moves up and down through a radius about the ends, with this centre section fixed, it allows the plate to shrink a little bit and stretch a little bit according to the radius of the thing moving. It doesn't sound like it's worth worrying about, but I worry about things like that, and I'd rather make sure it was all right, and it seems to be very good now. So the wires on the side here is 2 sets of wipers, 2 sets of reds and 2 sets of blacks. They'll be, well, I've used blue wire here, but that won't make any difference. And there's little wire wipers running on a brass tracks that I've fitted into the bottom there, so that by undoing these 3 screws you can just lift the bridge off, and the wipers and everything will come off, and you can service that and clean it and do what you like. Drop the bridge back on again, line it up with the tracks at the end and tighten up the 3 screws, and everything will be back to where you left it. And if you need to, the big aluminium positioning disc underneath, that's got 3 screws through that have got slotted holes, so you can just loosen those a bit and move the disc around a bit if you want to, in order to make sure the tracks all line up perfectly. So it's all quite adjustable, which was my intention right from the beginning. Now, there's one other little section of the speed control that I can put on here. If I can just come around here. And that's under here. Where did I leave the damn thing? I can't find it now. Oh, there it is. Hang on. It's becoming quite amusing, isn't it? So on here we've got just a few connections there, but at the top there's a little variable voltage regulator that I bought, so that you can, with a little screw on it, a little brass screw on that rectangular blue section, you can actually adjust the fast speed up or down a bit. If you think it's going too fast or too slow, you can vary it using that little screw. But if you do that, it might mean changing those other resistors for the slow speed. I had to use fixed resistors there because what's positive in one direction is negative in the other direction, so the resistor was the only way I could control the speed, because the voltage will reverse depending on the direction. Whereas this one here, for the main speed, it's supplying the 12 volts, or you know, it actually cuts it down to 5 or 6 volts to the motor, and the direction switch is after that voltage regulator. It's a bit hard to figure out, but when you see the wiring diagram, you see what I mean. So anyway, there you go. So I'll just try and add this onto that other video when we're finished.